Okay, chapter 12. We'll talk about the algebraic equations again. We just had a short introduction of algebraic expression and equations in the last chapter, which is chapter 11, which is finished right now, and we're going to start the next one. So again, we have some idea about the equations. The equation will have an equal sign. On the left side there will be an algebraic expression. Right side there will be a separate algebraic expression. And they both are equal for sure due to some, some logical reasons, some problem you are given. And remember, equality sign doesn't have to be always there. There may be some other signs which represents the inequalities. Remember, we have some other signs like less than equal, greater than equal, right? So not equal. Those can be also part of algebraic equation. Meaning, equations mean you have two sides, left side and right side. On both sides, you have two algebraic expression. In the middle, you might have an equal sign, you might have an inequality sign. So we'll see it here how both of this works for us. So now remember, when you solve the algebraic equation, a lot of time what you do is you are trying to find the value of unknown. Remember all the x, y, z, a, b, all sort of variables we have. One of those can be unknown. Given that everything else you know, I'm saying, let's say you have three variables and you know two and you have to find the other one. You can always do it just by isolating the unknown and solving it. We'll show you how to do it here. I think most of you have seen it in some point in your life somewhere, but if you have not seen it, that's still fine. But remember, in some cases, we wanted to show you that only an equal sign doesn't make anything equal unless they are not equal actually. Look at this one. In the left side, if you are saying 22 over 11, which is 11, the right side you are saying 11 plus 5, which is 16, they are actually not equal, okay? So everything has to be equal. So, whenever something is given as an equal sign. Now, let's see whether we understand a little bit of equation and see whether we have some understanding of how it is related to English, meaning whether we understand the meaning of that equation. Let's say it's given like this. When solving for x, many students will be careless in their work and they might write something like the following statement. How you do it? Let's say you write x plus 3 equals to 10. I have also done it in my life when I started algebra. What you do is you try to subtract 3 from the right side and you end up with the 7. But remember, in any sort of algebraic equation, if you do an operation in one side, because you are saying, I'm subtracting 3 from the right side, because in the right side you had a 10 and you subtract 3, but you are just keeping the left side as it is. You cannot do that. Whenever you have an operation to do, if you want to, then you have to apply the same operation in the both side of the equation. Meaning, if you subtract 3, let's say, in the right side, you have to subtract 3 from the left side as well, because otherwise the equation will not be equal anymore. And that doesn't make sense, because as long as they're equal, that has a meaning, right? So be careful about that. So the right representation, it is a fall. Right representation must be, let's say you said, okay, so now here you subtracted 3 from both sides. Okay, so be careful about those things. So for an example, this is also not true, because we are given like 2x equals to 20 and you are just dividing 2 from the right side. You have to do the same in the left side as well, okay? So the right representation would be you divided 2 by both sides, then that will be true, okay? So be careful about all of these. So we have shown you some example here as well. So this is how we do it, okay? Another example here. So whenever you do some operation, again, reminder, you do it in both sides, okay? You apply the operation in the both sides. Same problem here. We did it. Okay, now let's see how we basically use the algebraic equation and we find the unknown. Okay. Now remember, all the layers and all the variables you have, they can be unknown as well. Meaning one of the variables can be unknown, multiple variables can be unknown. Okay. And using one equation, you can always find one unknown. Remember this. Now let's say you are given one equation. Okay, there are like x, y, z, and several variables. Now out of all the variables, there are two unknowns, let's say. There is no way you can find the two unknowns using one equation. That means what? If you have one equation, at max you can find one unknown using that one. You have two unknowns, then you need two different equations to solve it. That's like we'll see in future, but just for now we'll see how to do this. Okay, how to just solve for one. Now, a lot of times what we do is to isolate the unknown and to solve it, we do by a function called transposing that involves reversing the arithmetic operation. Like if you have something added, to cancel it out, you subtract, right? Excuse me. If you have something multiplied, to cancel it, you have to divide. That's called transposing, because you are just reversing the function. I'm saying the operation. If it is addition, do subtraction, subtraction, do addition, multiplication, do division, division, do multiplication. If it is power, do square root. I'm saying if it is square, or if it is square root, do power. I'm saying you just do all the reverse operation, okay? And another way is, whatever you do in one side, that's probably easier for the beginners. I go by these in general for the beginners, that whatever you do in one side, you do the same in the other side. That's the most important part. We have been just showing you for a while how you do it, but why you should do that, because you should make it always equal. So you apply the same rules to the both sides, and always check by substitution that original equation still applies. We'll show you how to do that. For an example, let's say this is an equation you are trying to solve. Now, as you can see, there are only one variable and which is unknown. 2x plus x plus 5 equals 4. And let's say somebody gave it to you and somebody said, can you solve it for x? Meaning, can you find the value of x? How much is x? What do you did? You first added the x. You have 2x and 1x. You added. You got 3x plus 5. Now remember, what is unknown here? X, right? Whenever something is unknown, you have to isolate it. You have to keep it in one side, and you have to get rid of everything else from that side. That's how you isolate it. Now to get rid of everything, for an example, let's say you want to get rid of 5 first. Okay? How to get rid of 5? 5 is added, right? Just do the transposing. What do? You subtract 5. But remember, you cannot subtract only in the left side. Whenever you do something, both sides, right? So we subtracted 5 from this side. We subtracted 5 from right side as well. So at this point, it makes sense why we subtracted 5, because the 5 and 5 get cancelled in the left side. Now in the right side, it became -9. Still you are not done, because you have 3 multiplied with x. You have to get rid of this 3 as well. Now the 3 is multiplied, right, with x. How you get rid of 3? You have to divide by 3. Again, both sides. Divide it by 3 by both sides. Now you are end up with x equals to -3. That's exactly what you were looking for. You just wanted to know what is the value of x, because the x was unknown, right? Now you know x is -3. Now if you really want to see whether you did it right, you know that x equals to -3. You can apply it to the original equation you had. The original equation was what? 2x plus x plus 5 equals to -4, which is 3x plus 5 equals to -4. Now you apply the value of x. That means what? You replace the x by -3. You did that, and you got something like -5 plus 5 in the left side. You solve it. At the end, it becomes -4, right? Now the good thing is, if you did it right, your left side and right side will be equal after substituting the unknown by its value. Meaning, in this case, after substituting x by -3. And we see it here, right? That both sides are equal right now. So that means you did it right, your answer is right. Now, for multiple choice quizzes, you can always substitute the answer by your choices. Because in most of the questions we say, okay, what is the right answer out of these 4? We give you the 4 options. You can just choose one after one and apply it to the equation, substitute it and see it, right? Instead of isolating the equation and solving it. But I would always say, try your best to see whether you can solve it instead of just applying and substituting, right? Because in real life, this is not multiple choice, okay? You will not be given the answer as a multiple choice. Okay, let's see this. X plus 3 equals to 10. You can just see from here and know x equals to 7, because if you apply 7, that becomes 10. But that's how you can always see, not in all time, but in the easier equations you can just see and you can know. But if you really follow the algebraic way of doing it, isolating x, you should always do this. X plus 3 minus 3 both sides, right? Because you want to get rid of 3 from left side. 3 and 3 get cancelled, x equals to 7. That's what exactly how the algebra should, algebra should be done, right? But to solve the, isolate the unknown and solve it. Okay, we just did it here, just how we saw it. Okay, now let's see whether we can solve it here. 10 minus x plus 3 equals to 11. Let me give a pause here for a minute and see whether you can try and solve it. But remember, you can always go by the options and apply it, but don't try the options. I'm saying we can always do that, but we also want to learn how to do it just using the algebraic rules, okay? Let's see whether we can solve it, meaning you want to isolate x and see whether you can find it. I'll show you how to do that after a minute, okay? Let me give a pause here. Okay, if you solve this equation, this is exactly how it should look like. You first simplify, and then you subtract 13 from both sides because you want to get rid of 13. And then once you do that, you'll be just left with negative x equals to negative 2. So still you have to get rid of negative sign. So you multiply both sides by negative 1, because negative and negative makes this positive. So x equals to 2, which is the answer. If you want to verify, you can apply the 2 in the original equation by replacing x. Then left side and right sides are equal, so it's fine, right? Let's look at another example here. So how you solve it? So you are solving it for y. Remember, y has to be isolated. It can be either in left side or right side, doesn't matter. Let's see how we do it. We first want to get rid of this negative 11, right? To get rid of negative 11, you have to add 11 both sides. Did that, we cancel out 11s, and we were just left with negative y in the right side. Left side you have 26 after adding and subtracting everything you had, including the 11. And then you multiply y by negative 1 because you have to get rid of negative sign. Then it becomes y equals to negative 26. And then you apply negative 26 into both sides, especially in the right side because y was in the next right side. You solve it and you have 15 equals to 15, which is equal. So that means the equation is solved. So y equals to negative 26. Let's try another one. Now this time 3 is multiplied, right, with x, and you want to get rid of 3 because you want to isolate x. To get rid of 3, you just divide both sides by 3, which is simple, right? So you just divide 27 by 3 as well, so it will be 9. X equals to 9. Right answer is C, right? We showed here how to solve it. Another one. 4y equals to negative 64. So you want to get rid of 4, right? Multiplied by y, and you just divide both sides by 4. Once you divide, you get negative 16 in the right side and y, so you solve it, and last step you verify the answer. So you replace the y by negative 16, right? See whether the left side and right sides are equal. Another one here. 7 is divided. A is divided by 7, right? So you multiply both sides by 7 to get rid of this 7. See, you multiply both sides by 7 to get rid of 7. 7 and 7 get cancelled here. So that becomes A, and this side it becomes 42. A is 42. To verify, you plug 42 here. I'm saying once you plug 42 here, you see the right and left side are equal. Any question here? Let's check another example. This is a bit tricky because as you can see, the unknown is B, which is used as a denominator. How you solve it? Now you can have multiple ways of solving it. So what we did here, see, we have to bring it from the denominator to numerator position. So we multiplied both sides by B first itself. So B and B get cancelled in the left side, but you got a B in the right side. But as a numerator, which is a good thing because he wanted it as a numerator. Now still the B is multiplied by -9. So you want to get rid of -9. That's why you divide everything by -9, both sides. At the end, you will end up with B equals to 1 over -3. So B is 1 over -3. We apply B in both sides, I'm saying in the original equation, and he found that -9 and -9 are equal, right? We can try another one. Now this time, this is the first time you can see that you have unknown is X, but the X are in the both side, right? You have X in the left side, you have X in the right side. Remember, to solve it, you have to bring all the X's in one side. So either you want to get rid of the left side X or the right side X. What we did is, we decided to get rid of X in the right side. So in the right side, you have a -3X. So we added 3X there, because to get rid of that, you always want to add, since that was a subtraction. So we added 3X, both sides. Right side 3X, and all the X's get cancelled. So now you have all the X's in the left side. Now that becomes 7X plus 3X, -2. I'm sorry, not -2, +1. You want to get rid of this one as well, because remember, at the end you have to get rid of everything except X in the left side. So you subtracted 1 both sides. Now the right side becomes -10, left side becomes 10X. Now this time you want to get rid of this 10. So you divided 10 by both sides. Then you are left with X equals to -1, and you applied it to the original equation, and you can see the left side and right sides are equal. Another question here, how you solve this? Again, you want to solve it for A, right? Now, to solve it, you first get rid of the parenthesis, meaning you distribute 7. That means you are multiplying A by 7, multiplying 4 by 7, because you are distributing 7, right? This is the distributive property of algebraic equations. Now you multiply everything by 7 in the left side, you get 7A plus 28 equals to -7. Now it's simple, because you first want to get rid of this 28. To get rid of this 28, you subtracted 28 from both sides. You got rid of 28. Now it's 7A -35. Still you are not done, because you want to get rid of 7, which is multiplied with A. So what do? You divide 7. You divide everything by 7. Both left and right side. Then you will end up with a equals to -5. So you can apply the -5 to the original equation. Left and right side will be equal. So this is the equation with the exponents, meaning the powers and roots. So for an example, your equation is x cubed equal to 27. Remember, by the transposing law, what do? You reverse it, right? So if you have a power, to get rid of the power, you do the root, right? So the power is 3. So you have to do the cubic root. If you take the cubic root of both sides, left side become x. But the right side, this is a cubic root of 27. That means you have to find some number, a number which is multiplied 3 times by itself to get 27, which must be 3. If you multiply 3 by 3 times, that's 27, right? So x equals to 3. To verify it, you can apply the value of x to the original equation and see the left side and right side are equal. Another equation. Now this is the square root. Remember, to get rid of the square root, you will be doing the squaring, right? So here is a square root here. To get the square root, get rid of these, you square both sides. Then left side becomes 5x, right side is 49. You divide both sides by 5 because you want to get rid of this 5. When you do that, you will get x equals to 49 over 5. If you apply it to the original equation, you will see the left side and right side are equal. Remember, in pause, you might be given the answer as a mixed number, or you might be given the answer as an improper fraction. So check it, okay? It might be 49 over 5 given, or it might be 4 over 5 given. It depends. Remember, at the very beginning we said algebraic equations may have something else except equal sign. Now you will see that we'll have the algebraic equations with these symbols instead of equal signs. I'm saying these operators instead of equal sign. It can be less than, greater than, less than equal, greater than equal, not equal, all sort of things. Now, how do you transpose these? Inequality is a bit tricky because anytime you always want to get rid of, you want to always isolate your unknown. But the only problem is whenever you have an inequality, if you divide or multiply by negative number, inequality get flipped. We'll show you. Meaning, if the inequality is negative, it is less than, it becomes greater than. If it is greater than, it becomes less than. Okay? Let's see some example. Okay, here you go. A equals to a plus 13. Again, all you need to do is you want to find the value of a. You cannot probably find the value of a here. You probably find the range of a because this is inequality. Okay? But what do you need to do? You have to isolate a, right? How do you isolate a? You have to get rid of this 13 added with a. That is added, right? To get rid of that, what do you do? Subtract. So you have to subtract 13 from both sides, right? So if you subtract 13 from both sides, let's see how it should look like. If you subtract 13 both sides, left side it will be a, right side it will be 9. Now, what exactly it tells you? See, this is not saying a equals to 9. This is saying a must be equal or less than 9. Meaning, anything, because since this is not an equality, it will not tell you exactly the value. It will tell you the range of the value. Okay? Now what it exactly tells is, anything, any value of A which is 9 or less will satisfy the equation, algebraic equation. Let's see how it works. Now let's say, to test it, we have chosen 3 values, 9, 0 and 13. Now for 9, I applied into the original equation, and we found it's 22 less than or equal 22, which is right. 22 less than or equal to 22, right? I'm saying 22 is equal to 22, so that's true. Now, the second value we have chosen is 0. We applied it here. You see, 13 less than equals 22, which is still okay. This is still true, right? But the last value is 13 we have chosen, which should not be the right answer. Because original inequality said A must be 9 or less. 13 is not less than 9, right? Let's see how it works. If you apply 13, that becomes this. 26 is less than equal to 22, which is false. I'm saying we just wanted to show you that how the inequality works. You can try a lot of values. If the value falls into the range that has been found by the inequality solution, it will solve the equation. It will give you a range, but it will solve the equation. But otherwise, that will be a false answer. Okay? So, how about this one? We are trying to see how you solve this equation. Okay? Negative 12. This is a bit tricky. Let's see how you solve it. Okay, to solve this, look at this. You have multiple things multiplied, divided with x. And you have to get rid of everything here. So let's say I want to get rid of 7 first. To get rid of 7, what I need to do? 7 is used as a new denominator here, right? So we have to multiply everything by 7. Let's step 1, I multiplied both sides by 7. Once I multiplied, everything is okay. Now it becomes negative 84 here, and this 7 and 7 get cancelled here. You are left with negative 3x. Now, still you want to get rid of negative 3, right? How can you get rid of negative 3? You have to divide by negative 3. Now, this is the time you have to be extremely careful in case of inequalities, and which is quite different than the regular equalities. Now, look at this difference. The difference is here. You are dividing by negative 3, which is fine because you want to get rid of negative 3. But look at this. After the division is done, do you see the symbol is flipped? Do you see it is flipped? That is the critical part. If you are dividing or multiplying by negative number, see, we divided by negative number, right, which is negative 3. In any kind of inequalities, if you do it, your symbol get flipped, meaning if it is less than or lesser than equal, it becomes greater than or greater than equal. If it is greater or greater than equal, it becomes lesser than or lesser than equal. Okay? Be careful about this. If you do anything with the negative number, meaning anything means division or multiplication, don't do it when you are doing addition and subtraction. Okay? It's only applies when you are doing multiplication or division. Then this changed. Now remember, 28 less than x means what? X equals to greater than 28, right? Which is the same thing. That means this inequality tells you that any value greater than 28 will satisfy this equation. Remember, 28 itself will not satisfy the equation because it is only greater. That means it tells you that anything greater than 28, right? But 28 itself is not a solution. Let's see how it works. In the next page, we'll try to see, we will try to apply some value. Now, according to the solution, again, x must be greater than 28, right? So we have chosen two values. One is 0, another is 35. Now technically 0 should not be the right answer, right solution, right? Because this is not greater than 28. We tried it, we applied 0 in the original equation, and we found this, negative 12 greater than 0, which is false, right? Because any negative number is less than 0. That is not a solution, right? We know it, and we just tested. But next one is what? 35, which should be the solution because 38 is greater than 28, right? We applied it and we found this. Negative 12 is greater than negative 15, right? Which is true. Right? Negative 12 is larger, right? Greater, right? So 35 is a solution, which should be, right? Because anything greater than 28 should be a solution. 38 is a solution. But remember, in case of inequalities, you don't have a specific solution. You have a range of solution, meaning anything greater than 28 is solution, right? 29, 30, 31, 32, even all the fractions, right? Even if it is like 32.9, that will be a solution because that's greater than 28. Anything greater than 28. How many numbers you have greater than 28? You have infinite numbers, right? So all the infinite numbers you have are basically the solutions for this equation. Okay? Now, this is pretty much the end of the chapter 12. Remember, today we talked about chapter 11 and 12, and in both chapters, we have not covered the whole chapter. We pretty much covered the range of the pages. We have given at the beginning which pages we are covering from the books. In case you are using the book, you can see those. Now we'll go to the quiz section and pause, and let's finish the quizzes for chapter 11 and chapter 12. Okay? In next couple of classes, we will basically cover the trig. Okay? Since we started the algebra, as you can see that we are directing towards the trig. So we'll talk about the volumes, perimeters, and see how we can use the algebra to solve the trig problems. Okay? And the final will be a comprehensive one, okay, which will pretty much cover everything we have talked about in this class, except those successful technician part, which was the bonus, right? Let's stop the presentation here for chapter 12.